Hello, everyone. We'll just wait a second while the doors are open. We've got a great group to listen to today and super high attendance because this is a hot topic. Let's wait one more second. My name is Dr. Margaret Whitaker. Most people know me as Meg, and I'm program co-chair with Colleen. And we're presenting today an interesting webinar called Accounting for Mobility and Alternatives Assessments, Insights from the ZeroPM project. So we've got them for an hour, and we do have time today for Q&A. So this webinar is hosted by the Association for the Advancement of Alternatives Assessment. I'm a proud member of A4, and I hope those of you who are listening today, if you haven't joined A4, you will join A4. It takes 2 seconds. It's very easy at the link here, and it's important to become a member. You get lots of information on the email list. We share A4 content, and we're here to support each other in as we go on our journey of alternatives assessment. So welcome. Today we'll hear from researchers involved in the ZeroPM, Zero Pollution for Persistent Mobile Substances project, and we're going to hear about their efforts to try and address hazards of these substances in the AA process. So we have 4 primary goals today. We're going to learn about new criteria recently adopted by the EU Commission relating to this. We're going to explore the essential use and substance grouping concepts as related to such substances. We're going to consider these implications for AAs, and we're going to learn about case studies that talk about this. And we're going to explore the use of big data for identifying functional alternatives to PM substances. So we've got a great panel today. We're going to start off with our main presenter, Hans Peter, who's the project coordinator for ZeroPM. He's a professor at the Norwegian Geotechnical Institute and the Norwegian University of Science and Technology. We also have 3 respondents. We've got Greg Peters, who's a professor at Chalmers University of Technology, Romain Fuggieri, pardon me if I mispronounce it, who's a PhD student at the Stockholm University, and Ian Cousins, who's a professor at Stockholm University. So we've got 42 slides to go through today. So I'm going to turn over the baton to Hans Peter, who's going to go through this with us. And thank you again for presenting to us today, Hans Peter.
Yes, well, hello, everyone. Good morning. I guess it's still morning in America. It's late in the day here in Europe. And yes, I'm calling from Norway, and my colleagues are joining from Sweden. And I just want to thank A4 and Molly and Margaret and all the people who made this event possible. So a lot of material I want to cover and discuss with you all on this presentation called Accounting for Mobility and Alternatives Assessment Insights from the ZeroPM project. So first, I'm just going to, you already got a taste of what I'm going to talk about, but the parts of my talk, I'm first going to talk about chemical mobility, because not everybody knows what that is, how that relates to the project that I'm representing, the ZeroPM project, the updated criteria in Europe that was mentioned, and how to account for mobility and alternatives assessment. This is the real meat and potatoes, and also essential use in alternatives assessment. And then these are things that are pretty far developed, and then I'm going to talk to you about things that we are developing further in the project, such as stakeholder perception, sustainability assessments, tools for market transition, and big data cheminformatics, databases and tools. Now, I'm going to start also with a quote when I talk about what is chemical mobility, because something that we're seeing a lot of in the data of the new chemicals being brought into the market is that there's a lot more of them. And in particular, there's a lot more mobile chemicals. And this was something that was predicted in 2008 by Professor Pim de Vocht on the screen when he was wondering how the market might respond to all these regulations about bioaccumulative compounds that accumulate in the food chain. So he said the European REACH legislation will probably drive producers to innovate their products, possibly to develop newly designed chemicals that will be less persistent, bioaccumulative, or toxic, but this may result in higher mobilities of chemicals in the aqueous environment. As a result, the drinking water companies may face stronger demands on removal processes, as the hydrophilic compounds inherently are more difficult to remove. And you might have seen a lot of news and recently. There's more and more scandals, especially in the United States, about contaminants in drinking water. The most notorious, of course, are PFAS. There's a lot of actions going now with the EPA and the many states suing companies like 3M and DuPont for pollution of water with PFAS, which are one of the most notorious of the PMT chemicals. So this is part of the reason why this issue has been rising on the agenda, and I'd say not only in Europe, but obviously in America and China as well. We're seeing more and more interest in this. But let's talk about, how does contaminant get into drinking waters? Well, obviously these chemicals were made somewhere. We're talking mainly about synthetic chemicals. So, and these, after chemical synthesis, these were designed for some kind of use or product. And either at the synthesis phase in the chemical factories or where they're being used, there's a chance of environmental emissions at all these points. And then once they're in the environment, they can transport through the environment or through infrastructure like wastewater treatment plants. And then they can go further into water treatment production and then end up in my son's water bottle on the screen there. And we don't want that, but we have to think, in addition to all these transport processes, what are the properties of these contaminants? And they have to be persistent and mobile, persistent enough that they don't degrade during this long journey, which can take days, years, and they have to be mobile to actually make this journey. It's not a direct route. So that's the persistent and mobile. And next slide, next click. If they're toxic, then we have to be really concerned about them. And that is kind of the origin of PMT. And there's a lot of attention on PFAS especially, but something why it's not just a PFAS criteria is that there's a lot of other contaminants that we're seeing more in drinking water that have these PMT properties that are not as well known, but some of them are these ones on your screen. These are novel ones that we found in the past 5 years. And maybe by their chemistry, you can see why they are persistent and mobile. They have for instance, highly three-dimensional structures or highly substituted structures, which are difficult to break down. And you can tell by their high polarity that they can be quite mobile. And so now I'll talk about where the ZeroPM project came in. It was to deal with these type of substances. And what we're trying to do is interlink and synergize 3 strategies to protect the environment and human health from persistent and mobile substances. And the 3 strategies are prevent, prioritize, and remove. And we are 18 months into the project. It's a 5-year project, and it's got a relatively large budget. It's 11.6 million euros. And it involves 15 institutes throughout Europe, which you can see on your screen here. So I can first explain a little bit about the logo. The logo is based on something that's called the toxic-free hierarchy, which is a European Commission concept about the best ways to deal with chemical pollution, where the best is obviously prevention and the worst is removal, because that means it's already in the environment causing problems. So obviously you want to prevent the problems. And we want to create a multi-level framework involving many stakeholders to discuss this 3-pronged strategy to better manage or to better prevent, prioritize, and remove PM substances. And this involves chemical industry, policymakers. The drinking water sector is a huge part of our extended stakeholder group, and also people involved in remediation. Now back to prevent, prioritize, and remove. We think they're interlinked. They're interlinked strategies because we want to prevent, for instance, regrettable substitution for the prioritized PM substances by assessing hazard, sustainability, exposure, and removal. And we say prioritize because we can't deal with all of them at once. We have to start somewhere. Prioritizing PM substances and groups based on intrinsic properties, exposure, and hazard to select those that are most urgently needed to prevent and to be removed. And we want to develop technology, or to understand the limits of the technology of removing prioritized PM substances by effective, sustainable, and safe remediation methods that prevent unfocused remediation effort. And so now I'm going to relate this to the next part of my talk, is to take it to this new um, criteria from the European Commission for PMT substances. And this was part of a plan that was announced in 2020 called the EU Chemical Strategy for Sustainability. This is kind of the roadmap for the up and coming EU regulations. And it was big news as part of the strategy that the PMT and the vPvM hazard criteria, and I didn't say vPvM, that means very persistent and very mobile, has been officially adopted in the CLP regulation and put in force on April 20th, which means that now European chemical manufacturers will need to do PBT and vPvB, as well as PMT, that should say vPvM, substance evaluation and labeling to bring them on the European market. So this applies to all industrial chemicals, to all plant protection products, or aka pesticides, as well as biocides. So this will have to be done, and there's a roadmap to when these new hazard labels will have to be on the material safety data sheets or on the products. The labeling is still being discussed, but it'll of course start with the single substances will have to be evaluated for PBT, PMT, and then eventually mixtures. So there's a timeline to do that, and the European Chemicals Agency is now actively making a guideline on how to do that assessment. But just very briefly, since it's a short seminar and we can do a deep dive on this, but in Europe, they use this new CLP criteria to have the exact same persistent and very persistent criteria that is found in the European Industrial Chemical Regulation REACH. And that defines persistent and very persistent based on media-specific half-lives that are based on simulation tests. So for instance, if a substance has a half-life of 120 days in a simulated soil test, it would be considered persistent, and 180 days would be considered very persistent. They recommend all these simulation testing should be done for all compounds, but in practice, it's very rare. If you're lucky, you'll get one simulation test for the compound, but they encourage all testing. And if it's persistent by any one of the definitions on the screen, it would get the persistent label. Next slide, please. But the new one is mobility. So how do we define mobility in the environment towards drinking water? And this was a process that I was involved in for many years now, but now the official definition is up, and it's based on the log KOC, which is the organic carbon water partition coefficient. It's sometimes called the soil adsorption coefficient. It is determined by a test called the OECD 106 test, where you measure the absorption of your chemical to different soils. They encourage 5 different soil types, and you can derive a KOC. And this is particularly protecting subsurface transport. KOC is very relevant when you're doing groundwater modeling for organic contaminants, because the organic carbon content is typically what is absorbing the contaminant and having a big influence on its mobility in groundwater. It's also relevant for water treatment processes like sludge treatment plants. So if this value, the log KOC value, is less than 3.0, it's considered mobile, and less than 2.0, it's considered very mobile. But one thing is that this is a new criteria, and so it's not really included in any of the typical alternative assessment frameworks, certainly not the classical ones, which is understandable because it's a new criteria. And some of the first research I went to do, this was in collaboration with Greg Peters, who's one of the respondents now, with a PhD student, Jie Zhang, to develop ways to include mobility in alternative assessment frameworks. And so this is just an example. This is actually before ZeroPM, but it's one of the things that we were thinking of when we were designing the project. And so this was a case study we did to look at alternatives for the hazardous chemical decabromodiphenyl ether to see all their alternatives. And we were mainly looking for organic alternatives, so we didn't look at things like magnesium hydrides or antimony. We just looked at the organic ones. And the idea there is that we wanted to develop methods for this. So The first, the most straightforward approach is to make some heat maps. So on the chart there on the screen, we have a list of, we have deca-BDE in the first column, and then we have a series of alternatives to the right. And as I showed you before, we looked at persistence, for instance, based on these reach categories, these reach media. So we have different categories of persistence, bioaccumulation, different toxicity endpoints. And at the bottom there is the mobility of all the alternatives. And so this heat map, we can draw a lot from a heat map, but we want to do something that will help us integrate all these diverse endpoints, because we realize with the more hazard criteria, it's harder to use heat maps to make decisions. And two of the approach that Greg was very instrumental in developing was the use of MOUT and Electra3, which are two multi-criteria decision analysis approaches that were taken from the finance industry, basically, or like these are methods that hedge fund users would use. But the first theory, what it does is you have to put the P, B, and M criteria into comparable scales. So that also devolves a lot of value judgment. And then you have to make some trade-off weighting factors to represent the relative significance of each criterion to be assigned in order to permit aggregation. So it's it's a lot of value-based judgment, but it lets you weigh, for instance, P versus B. And the other method was it's slightly more complicated, but it involves the building of a credibility matrix, which presents to the extent at which an alternative outranks the other alternatives. And you have, instead of these trade-off weights, you have importance coefficients, what is the most important, but you can also sneak in uncertainty. So for instance, if some of your data is more uncertain than others, you can use like certain thresholds for when you would consider something to reach different levels. But we could aggregate all this together, and then we can make these combined assessments. And then this kind of helps put out identify which is the better alternative. So in this case, it'd be the 17, the darkest would be the worst, and the lightest, number 1, would be the best. And then from this initial study, we found that the two best alternatives from this method was one called BHT-BP and one was called melamine. So BHT-BP was relatively less toxic. It's not mobile, but still persistent, a bit in sediments and some toxicity, but overall it was the best. And the other one was melanine, which was the least toxic of all the things that we looked at, but it was also the most mobile, and it was still toxic. It's toxic to kidneys. So it is actually a PMT vPvM substance, but it's one that we thought was actually safer than decabromidiphenyl ether. Next slide, please. Oh yeah, and I should just mention on we can keep it on this slide, but we also said that I think this is something that's typical in alternative assessments. You're never going to get a perfect chemical. You're just going to get at least worse of alternatives. But now we can take it forward to original the ZeroPM research, and this was co-written by some ZeroPM members, Zhenyun Wang and Ian Cousins. And it was about how to bring the essential use concept and functional substitution concepts. And so as part of this, there was 3 steps. You have to analyze, is the technical function of the chemical necessary for the performance of the product? Number 2, are safer alternatives available? And number 3, are they necessary for the health, safety, or critical functioning of society? So I will walk you through an example that the respondent Romain Figure with Ian Cousins developed. So with also Joanna van Dijk from another project, they wanted to look on alternatives of PM substances in cosmetic products. And they looked at one called climazole, which is an anti-dandruff agent. Next clicks, please. Benzophenone, which is a UV filter and UV absorber in all types of cosmetic products, and also a pigment called Allura Red. So we'll talk about these 3 ones. Well, first we want to look at the technical function. Does this thing actually do what it's supposed to do in the product? And in climazole, yes, it does work as an anti-dandruff agent, so it fulfills the technical function. Benzophenone, it has 2 uses. One is as a UV filter in the sunscreen. and it does have the function of protecting against UVB and UVC radiation. So it is a protecting from skin diseases, and it can also increase the shelf life of the product so that the solution stays stable over time, even when exposed to sunlight. So it does fulfill a technical function. And then Allura Red, it's used as a pigment, for instance, a pigment in lipstick. So people have, for instance, red lipstick, but it's also used in the marketing of products. And for marketing of products, it's not necessarily necessary. You don't necessarily need that pigment to sell the product. So in that case, it's considered not to have the technical function fulfilled, but it still has a technical function of a red pigment. And so what they did, what Romain Figuer and Joanna van Dijk and others evolved, was they did an exercise similar to the first one I presented with the alternatives to DECA-BDE. And that was to look at what type of persistence available, bioaccumulation is available, and mobility information is available. And you can see on the screen, they looked at experimental data, but also predicted data. And they also considered the data gaps. So there's also quite a lot of data gaps for what they get for their various endpoints. So this is an overview of the data that they were able to collect and from various sources. And of course, we always say the fewer the data gaps and the more experimental data you have, the better your assessment. But what they conclude using the same methods with heat map, mount, and Electra, they were able to identify safer or better alternatives than those 3 case studies. As you can see here, and these are indicated in green. So for instance, in the case of Allura Red, the best performing chemical in terms of this assessment was beetroot red. We don't know that, but it's a natural extract of beetroot apparently. But there was also chemicals that were worse than Allura Red, like acid red 180. It's almost in the name. I can almost tell you that it's worse based on the name. But that did worse in all the methods of alternatives assessment. Same with benzophenone 4, there was a better alternative, and solizol, and worse one, benzylidine camphor sulfonic acid. And for clombazole, there's actually several safe alternatives: octanoic acid, capryl-glycine, shikimic acid, okay, and cyclopyroxolamine. I should have practiced these, but yeah, but there were safer alternatives. So that's an example case study. Next slide, please. And so now we can talk about essentiality, because though these examples, they did have a technical function, we could identify safer alternatives, and therefore their use is considered not essential in the process, and not essential for these products. And we did not have to go to the next step of looking at the health and safety of society, because we can already identify a safer alternative. Now I'm going to go to just some things that are in development, because I see time is moving. And so this is just to let you know things that we're working on. Next slide, please. So the first is to consider the concept of stakeholder perception and the essential use concept. And we have some environmental psychologists that are looking into this, but they're doing in this other dimension, in this next dimension, like maybe we can find better alternatives, but will these alternatives be taken up by diverse stakeholders, like from the market to the policymakers to society? So they do a lot of interviews and assessments, and they're making these mental models to what different people will think about the adaptation of safer alternatives. Long story short, but this is something that we are actively looking on. And this is another aspect that Greg is involved in. When we presented the examples of the alternatives assessment, we just looked at these properties and hazards of persistence, bioaccumulation, mobility, and toxicity. One thing that's kind of out of scope in a lot of these assessments is what is the life cycle impact over the entire use of the product or the chemical. So if we think of the lifestyle of chemicals, and particularly with persistent mobile chemicals, a particular issue is water treatment, because if these things are entering the water, we also have to think about the sustainable cost of actually having to remove them. And for some of these PFAS, the removal costs can be quite extreme. and environmentally intensive. And so this is a case study site where we're developing water treatment methods in the county of Rostock in Germany. And this is an area that has become severely contaminated with PFAS due to a bad actor putting paper sludge in the local compost. And this made the local drinking water non-potable, so they have to get their water shipped in, but they're trying to reverse it by using reverse osmosis so that it's potable again. And we're working with these people in the project to understand the costs of that and consideration of that when we develop alternative assessment approaches as well. We also work very closely with Chemsec, who many of you might know. They're an NGO based in Sweden, and their role is to interact with industries that want to transition to safer chemicals. And two things that they're doing particular through ZeroPM is to develop something called the PFAS guide, which is already online now. You can check it out on your screen. So this is actually something that's done, but it's to give, in particular, companies that want to get PFAS out of their supply chain, their value chain, out of their product, give them guidance on how to do that. And the other tool that they're developing is the marketplace, which is kind of a matchmaker place to help innovators who are making alternatives to PFAS and other hazardous chemicals and PM chemicals to businesses. So if somebody says, I want to get rid of this chemical, can anybody help me? And maybe an innovator has an alternative, or innovators can also sell. So we're targeting about 80 new chemicals that we can make match makes on the marketplace. And finally, I didn't get too much into it because it's running out of time, but this is something that I'm very much involved in, is developing the big data approaches for alternative assessment. So one thing that we have done already is we've unified all chemical inventories in the global chemical market. This was some earlier work by our colleague Zhenyun Wang, but we've redid this, and we have now a database that's connected to APIs of chemical inventories around the world. And you can actually see it now if you go to database.zeropm.eu, even though I didn't really release it yet. And these will give us chemicals. And what we're trying to do is, in addition to just information about the chemicals and what countries are producing them, is to get this information like persistence, mobility, and ultimately use data. And in collaboration with Romain and Ian, we're using part of this, we're connecting this to another database called the Alternative Assessment Database, which will be built up around particular case studies like the one with cosmetics, but we're going to keep building those up through a cheminformatic approach. Yes, so this is ZeroPM in a nutshell, and so I just had to give you a little taste of the other things. But in summary, the project ZeroPM seeks to incorporate alternative assessment, the following things: mobility in terms of the PMT vPvM criteria, essential use, stakeholder perceptions, sustainability and life cycle impact analysis, tools for industry and policymakers, as well as big data approaches. And I just want to say something else we're involved in now, that we have the PMT vPvM criteria in the UNGHS. The next horizon is to get this into the United Nations Global Harmonized System. And I know over summer, there's going to be some OECD meetings and some other high-level meetings as this is being negotiated. So if anybody is involved in that, we would love to hear from you, because we're trying to make a network of people who are doing this. So there might be some coordination. Yeah, and so with that, I'll just say thank you. And for your attention, and we can have I'm looking forward to the discussion right now and what the respondents have to say. But I just go to our website at zeropm.eu, and you can get access to all kinds of information. And you can also find us on Twitter, on YouTube. We have almost 70 movies about what we do, and LinkedIn. So thank you very much.
Wow, that was great. Thank you for being so persistent and moving through those slides with great mobility. So I'll turn the baton over to Colleen. Why don't you introduce Colleen? We've got our respondents here. We still have you moved this through the slides really well. So we've still got some time. So Colleen, why don't you take it from here?
Okay, thanks, Meg. Thank you so much, Hans-Peter. That was an amazing overview of so much work you're doing. So we wanted to take a few minutes to give some of your collaborators some time to add some additional insights. So we're going to start with Greg Peters.
G'day. Yeah, thanks for that intro. And good show, Hans-Peter. What I was thinking about in terms of commenting on this is there was a great paper about 15 years ago now called, well, it was all about developing models for assessing the risk posed by chemicals. And the sort of byline was the search for harmony and parsimony. And I think that's really a lot of what we're trying to do here. I don't think that there's ever a perfect tool or a perfect approach, but we've got horses for courses. And if you're trying to prioritize interventions in a company management plan or design legislation for a country or for the European Union or design new products, or maybe you're dealing with an environmental remediation question, your information needs and your information supply are so very different. And so I think in ZeroPM, we'll be probably looking at a couple of different ways of doing things, kind of depending on what the end use of the tool is. We've mentioned life cycle assessment, and for that we need to use a lot of data to model the, let's say the toxic or the spread of chemicals, their distribution in the environment, and the effects that they cause. And there's a method we call UseTox, which is very popular. Perhaps it's the consensus method of the day, but it's very data hungry. So if you want to use it, you end up having you're needing a lot of time and expertise to try and apply it to new chemicals, particularly these PM substances. So there's issues there. So sometimes we look for simplified methods, and in a parallel project, Chalmers University Technology and our neighbours over here, the IVL, Swedish Environmental Research Institute, are looking at a thing called ProScale, which instead of worrying about all the details around the EC50s and the KOWs and all of the other inputs that you need for a UseTox application, we build it on the H phrases under the GHS and CLP regulations. So it kind of comes with a pre-baked toxicity assessment. So you avoid some work that way, but of course it's at the cost of precision. And then even getting into the nice examples from that paper of Zhizheng and the rest of us about using heat maps or MAUT or Electra. Each of these methods will appeal for different situations. I mean, the heat map, I read a doctoral thesis lately that went on about how that is really the best method to use because you don't lose data. In other words, it's sort of more a fundamentalist approach to multi-criteria decisionating, because you try and avoid bringing too many pieces of data together and mushing them into a nice tasty blob to get a single figure out. I mean, and then Electra, of course, the opposite. We try to come up with a ranking and find the best based on a single index. But you know, it costs you something to do that. You lose some data, and you also end up having to introduce various thresholds, an indifference threshold, a preference threshold, a veto threshold, and weight. So yes, there's more kind of human assessment brought into it. So there are pluses and minuses with each of these methods. And I think as we go through this project and other projects like it, we're going to have to consider a suite of different alternatives for different kinds of applications. Is that about how much blurb you wanted from me?
That's perfect.
Okay.
Thank you. Well, I wanted to pass it over to Romain next.
Hello everyone. Thank you, Hans-Peter, for the really nice presentation. I wanted to expand a bit on this interaction between the essential use and functional substitution that we used in the study on cosmetic products. And actually, in their chemical strategy from the European Commission, they want to implement the essential use in REACH to manage hazardous chemicals, and they work together with the consulting company to figure out how they could do that. And WSP, which is the consulting company, they released their report in April this year, where they suggest that the essential use assessment should be focused on the technical function that the chemical is providing, and the assessment should focus on whether or not this technical function is essential. So we took this approach, and we think that functional substitution concept is really helpful and really useful to do that, because by combining the technical function of a chemical with its end use and the service it provides, we are really able to understand why a chemical is present in a product or a process. And the best example, I think, that Hans-Peter presented earlier is this area red, because in some cases it's used in makeup to provide the color red to a makeup, so like the lipstick. So of course, if you get rid of the red pigment in a red lipstick, then the lipstick is losing the color red. So there we can say that the technical function of the pigment is necessary. But in the case of a soap, in a soap, the use of a soap is to clean yourself, but whether it's red or not, it's not going to change the end use of the soap. So in that particular case, we can say that the pigment is not necessary and then non-essential. And we think that by doing such an, taking such an approach, we can identify those uses of hazardous chemicals for which the whole alternative assessment is not needed. Here, for area red in the soap, we don't need to find an alternative. We can just phase out the use of red pigment, for example. Yeah, I think that's it from my side. Thank you.
Great, thank you, Romain. And Ian, are there additional comments you want to add?
Yeah, thanks, thanks Hans-Peter for a great talk, and hello everybody. I'd like to emphasize, like we have done in many of our papers, the importance of persistence as the underlying driver of many chemical problems. And I conclude that the addition of the mobility criteria, which is basically another partitioning criterion, along with bioaccumulation potential, just further underlines the importance of persistence in chemical assessment methods, including alternatives assessment. You know, in the EU, we're proposing to regulate the entire class of PFAS on their high persistence alone, even though they're a very diverse group of substances with diverse partitioning properties. And it makes good sense, though, because there are examples of high persistence causing environmental problems for the entire chemical partitioning space, not just for PFAS, but for many other chemicals. And I could go through and give you examples for each kind of partitioning where there's a problem associated with environmental persistence, but I suggest instead you just read some of our papers with all the examples in. Now, as persistence is the driver of many chemical pollution problems, it really is a driver. Maybe it's the only thing you need really to show that you're going to have a problem with exposure. Maybe you can ignore some of the partitioning criteria like mobility and bioaccumulation potential. It's a bit controversial to say that, but after that talk, but if persistence is the main driver, then we need to have good methods for estimating persistence. And currently, we do not have good methods. We have quite poor methods for measuring or estimating persistence. And I think that's an area, maybe we're not doing it in ZeroPM, but maybe we definitely need to focus on our research on better methods for estimating kind of environmentally relevant persistence. It can be with simulation tests, like Hans-Peter said, but these are not perfect. But we need to have good test methods for this going forward. So that's basically my reflection.
Great, thank you, Anne. Well, we want to open it up for anyone who has questions, and I believe my co-chair, Mike, would you like to come on and ask your question? Or I can read it.
Hi, everyone. So my main question relates to a lot of our clients are using suppliers who aren't located in the EU, so they're not following CLP. So what's a simple way for particularly maybe American formulators to require suppliers to disclose PM-related hazards, because we're not regulated, for example, under CLP. So lots of people are purchasing very persistent, very mobile chemicals, and they have no idea. So are there some simple other than saying, we'll tell them to follow CLP, what are some simple ways, if there are any, that formulators can try and identify these PM-related hazards or substances?
Yeah, that is a tough one, and it's kind of, I'd also say, related to with what we're seeing from the other side. I mean, now that the industry has to have these new hazard classes, they are wanting other regions to also adopt them so that they don't have to deal with these transporter issues that this kind of curtails, and why we want it in the UNGHS. But I don't know, from my Eurocentric point of view, I would say the easiest would be to see if there's information of that chemical on the CLP database. I mean, because this would be, which is available from ECHA. And this information will be on there soon, because with information of the CAS number or other identifiers, you should be able to link it to what the criteria is in Europe. So then you just know if the Europeans had any objections to that chemical based on PBT or BMT.
Thanks, Mike. Hans-Peter. I do see another question from the audience in the chat. I don't know if Val would like to come on, but I can also share the question here is, given that a type of fluoropolymers are needed for the development of electric car batteries and green hydrogen, what do you think about the trade-off and balancing between the two ecological agendas?
I give that to Ian, that's his specialty.
Yeah, okay, I can answer that one. I would say that there's definitely a myth being generated that the fluoropolymers are essential for the green energy transition. But if you look in detail at the uses of fluoropolymers in for example, lithium-ion batteries and solar panels and wind turbines, etc., there are alternatives in almost every case for the use of fluoropolymers. An example would be the case where it's claimed that fluoropolymers are essential for use in lithium-ion batteries, using, for example, many of us will have electric cars and feel good about having an electric car because we're part of the green energy transition, but they have many PFAS in the lithium-ion batteries, including in the electrode. The binder is a fluoropolymer that's used on, for example, the cathode of a lithium-ion battery. But there are alternatives. There are PFAS-free alternatives, and many companies already have these on the market. And they contacted me, and told me that we've developed these, and there are many companies that have developed these PFAS-free alternatives for binders in lithium-ion batteries, and also in the electrolytes. Also, PFAS are sometimes used, but there are alternatives. So, we see sort of position papers by Kenmore's and others saying that they're essential, but quite often that's not true. Now, I'm not saying it's not true in all cases. There are cases where they are difficult to substitute PFAS, and we should look at each use case and we don't want to sacrifice the performance of the batteries, of course, because it's important in the green energy transition. But I've been told by manufacturers that we don't have to sacrifice the performance. There are alternatives, but we need to look at all of these use cases in detail and really determine the facts, and not just necessarily listen to position papers by manufacturers who are going to definitely benefit huge profits from continuing to sell these products. So they're not impartial when they make these position papers.
I see a follow-on question. Would you like to come on, Joel, and ask?
Sure. Thank you. This is great. Well, I have a couple questions. One, I just sent a follow-on to that one, Ian, because I was just talking with someone today who's working with a company that's making an alternative in the electrodes, and it's and the alternative is carbon nanotubes, which we're actually, Molly Jacobs and I are working on a paper right now looking at how alternatives assessment methods can be expanded to look at where there might be regrettable trade-offs and how we think about our alternatives assessment methods, where we're comparing in some ways apples and oranges, right? A complex material versus a chemistry, and how we update those. I mean, any thoughts on how we make sure that when we are transitioning to these alternatives? Certainly we're working in A4 as well on a briefing paper with a set of electronics companies, because you tell an engineer they can't use something, they're going to find something else cool to use that does it. And they may not be thinking about whether there's trade-offs.
Yeah, it sounds like you talked to the same company that's been contacting me.
Yeah.
It might be, is it Eric Kish or and this? It might be. I think it's an American company anyway that have developed this alternatives, which is not chemical, like you say, direct chemical alternative, but it's no. But I mean, they have. It seems like this company have thought about this, the different trade-offs, and they were thinking forward, I think, and they could see the problems with PFAS, and were I think market leaders, and they have they have huge customers like General Electric and so on as well. So they I don't doubt that their technology works, but yeah, I don't know all the details regarding the various trade-offs one way or another with this technology, but it's something you have to obviously consider when you do it.
Yeah, I mean, this is one. Yeah, it's one of these situations where there's some kind of discussion to be had about where in the mathematical progression from the emission through to the impact you can somehow draw an equivalency. More specifically, like the USTOX method uses comparative toxic units. Can we do that for the nanotubes, and so end up with something that's at least denominated in a common way between these two options? I mean, but it's not just a question of toxicity here, is it? I mean, I mentioned for a reason the idea of remediation jobs as a situation where we might need to do some kind of assessment of the toxicity of long-lived, of persistent mobile substances. So when some of these water treatment colleagues in Germany might treat the drinking water to make it drinkable, they might typically be dumping the reject water with a concentrated PM stream back into the environment because maybe that's all they can do at the moment. To fix that might involve using a lot of energy, and so you end up not with a trade-off between different kinds of toxic cause-effect chains, but a trade-off between a greenhouse impact and toxicity impact. And so at some point we're going to have to bring some human values into this thing and stop believing that it's all about science.
Let me ask a follow-on. One thing I noticed when I was at the workshop in February, and is the ZeroPM project has been driven a lot by and certainly by the health science side and less by the sort of technology and chemistry side, even though you have some chemists in the project. How are you thinking about building that community where you're doing a lot of work on the problem side of identifying the problem? You have this alternatives assessment part, but then how do we sort of, drive that collaboration to get the solutions, evaluate them, and then get them into practice? Because ultimately that's everyone's goal, from the health science side to hopefully the technology side.
Mm-hmm. Yeah, well, maybe I'll respond to that one. I think our easiest entry into that is through the collaboration with ChemSec, because they're the ones that are in direct contact with the technology side. And then from there, we can branch out into the other aspects of ZeroPM, such as the towards health science, or also to the chem informatics side. But it's mainly from there that we're trying to get our input, and then that will feed into, for instance, our alternative assessment databases. Ian.
Yeah, I just add to that. I mean, it's not ZeroPM, but I've been involved in another wonderful project called the POP3 project in Sweden, and this is a project where they tried to focus on phasing out PFAS, and the project wasn't academics; it was small companies and large companies that clubbed together. They were all interested in phasing out PFAS, and we're looking for solutions, alternative solutions. So it was really it was quite inspiring to listen to all of these people talk to each other and talk about all the different solutions and they're very different applications. So there was ski wax company, there was companies that were making like paints, like spreading paints on surfaces and firefighting foams and many different applications of PFAS, but they all wanted to phase out PFAS and were looking for a PFAS-free solution. So these kind of projects are great, where, I mean, totally driven by industry, collaborating together. And it was actually funded partly by, the funding came from the government. So the Swedish government were putting money in, and they also had to put in-kind money in themselves, the companies. But it really was a good sort of kickstart, a great collab, the phase out PFAS in many of these branches.
Right. We've got a project, as I mentioned earlier, where it's really, we're trying to reverse the direction of the design process, perhaps with the tools involved. So I guess the history of how we do life cycle impact assessment and the development of the use tox model is a story about how academic engineers and environmental scientists got together with risk assessment specialists and sort of bred some kind of hybrid beast that works reasonably well for the life cycle assessment specialists now. But so we're trying to get it the other way around and say, well, let's go to Volvo, let's go to Norion and these companies and say, well, what would your perfect tool look like? And try and work our way back up do the back casting back to, could we actually produce such a thing? What level of information do these people need for their specific design and regulatory management tasks? So that's one approach to go. I mean, I think we hopefully can work from both ends and meet in the middle somewhere.
Great. I see there's other questions, Colleen, so I won't dominate.
Thanks, Joel. We do have another question that is, do you think that persistence and mobile definitions should be expanded to consider plastics and their transformations to microplastics?
Yeah, I can take this one. When we're talking about transformation products of substances, absolutely. And this is also something that we have a follow-up paper with Greg on the paper I presented about how to include transformation products. And something about, I'll just say transformation products in general, is that they tend to be more mobile because they have more functional groups on them and more soluble. But the question of, and I would say that also transformation of products of polymers that are chemicals. If they're microplastics, then I think that should be a different regulation, because that's not the same transport mechanism. Because this is the mobility as it's defined is a partition mechanism that's dissolved in water, and microplastic transport is more of a colloidal thing. So even though they might be mobile in certain environments, they wouldn't necessarily apply to that criteria. So it'd have to be another criteria.
Great. Thanks, Peter. I think we have covered all of the questions in the chat. I don't see any raised hands. So let me ask, and we only have a few minutes left. I'm curious that if you could tell me, one, is there things that keep you up at night? Are there chemicals that aren't in the news that you're most concerned about? And two, what are you most excited about?
Well, I'll say the chemicals that, well, the chemical that I'm talking about a lot and I'm kind of most concerned about is one that's called trifluoroacetic acid. And normally I take some time to present that because it's a transformation product of a lot of PFAS, especially like refrigerants, some pharmaceuticals, plant protection products. And we see a lot of evidence that this is accumulating at an alarming rate, and it falls within the PMT criteria. And it's increasing in ice cores, it's increasing in the ocean and groundwater ubiquitously. And it's below what they know to be a toxic level concentrations, but we just know that this is going to be on the planet for centuries at least. And so we don't want to cross any threshold concentrations because we don't want to reverse. And that's saying in mind that there's other chemicals that I would also put in this planetary boundary threat category, like the other PFAS. But I would say these are the ones that keep me up at night. And then Ian has wrote extensively about recently these chemicals that are planetary boundary threats because of global accumulation. And I'm excited about finding a solution to them.
I can add to that. One of the biggest sources of TFA is the use in fluorinated gases that are used in refrigerants, and these are used in millions of tons per annum, and it's by far more than any other synthetic fluorinated organic substance. And so this is the big source. The newest fluorinated gases, the substitutes of the old ones, actually are very big precursors to TFA. These hydrofluoroolefins, for example. And so TFA, if this continues, TFA levels are just going to keep skyrocketing like they're doing, going up by more than a factor of 10 in surface waters in the last couple of decades in the US, for example. And so that they're everywhere in our rainwater, and eventually they will cross a threshold, and then we can't do hardly anything about it. We cannot reverse it, and we'll just have to live with this long-term toxic problem. There isn't really a solution to reverse the contamination on the whole planet easily.
And just to add to that, like none of the drinking water technologies we are aware of work on TFA, not even reverse osmosis. So.
Yeah, not good. I'd have to just agree with the TFA as the bogeyman here of bogeymen and bogey persons. Some good news maybe. I don't know. It seems like the pace of European legislation and others is really accelerating lately. So there's reasons to be a little more optimistic about that than we would have been, I don't know, even 5 years ago. I mean, we had a project. It's not just the let's say the legislative front either. We had a project a couple of years ago, which is kind of what got me into thinking about fluorinated organics, called SUPFES, where we set out to try and find alternatives for the textiles and fashion industry. And what we found was that by the time we'd gotten funding, which of course is a slow process, it was government money, and got it, the PhD candidate tied and so forth, the industry had moved on. It was clear that the responsible fashion manufacturers wanted to do this quickly. It's not every day you see that in things you care about related to the environment. So, people know more.
More positive note, we are ending there. So we're at time. So thank you all so much, Hans-Peter, Romain, Ian, and Greg, for the great presentations and comments and discussion. We do have a couple more slides, and we do have a poll, and we hope that everyone will come to our fall symposium in Tacoma, Washington. It's on enhancing safety, health, and equity. And we have closed the abstracts. We've got a great set of abstracts the committee is reviewing now. And we'll be opening registration over the summer and hope to have the final program out in August. So thank you, everyone. And thank you, Meg and Molly and Jen, for helping us. And please respond to the poll. Have a great day.